In this video, we will see how the Quinn-McCloskey method can be applied to minimize an expression which is in a standard product of sum. Okay. So in the last class, we have discussed how can be applied to minimize a standard canonical sum or product expression. So the only change that is required when the question is a POS, the question would be like this: y of ABCD is equal to uh, suppose the question was y of ABCD is equal to, instead of sigma, it was pi m. It was pi m 0, 1, 3, 7, 8, 9, comma 11 and 15 using tabular method. All the steps remains the same. That is, you will be writing the binary equivalent of these max terms. So when it is pi, all these numbers will become max terms. So you will be writing the binary equivalent of this max terms, and then you will be grouping like this. You'll be grouping a group of 0, group of single 1, group of twos in that max terms, group of number of ones, 3. The number of ones in that group is 3. Then this becomes third group, and number of ones is 4. It becomes a fourth group. Just like what you did in the sigma calculations, the same operations you are repeating for the pi also. Okay, so all the representations are same. There is no change at all. And then from this table, you are comparing the 0th group with first group to find out any matching max term is there. M0 is compared with M1, M0 is compared with M8. Similarly, second group, M1 is compared with M3, M1 is compared with M9. Similarly, M8 compared with M3, M8 compared with M9. And then the group 2 and group 3 is compared. So M3 compared with M7, M3 compared with M11. Similarly, 9 is compared with 7 and 9 is compared with 11. And the last group, M7 compared with M15, M11 compared with 15. So when this comparison is taken place, only there is one bit change. Those will be combined to become a pair group. Okay. So in the next table, you can see when compared, 0 and 1 can be combined. Why? Because there is only one bit change, and when there is a one bit change, you'll be putting a changed portion. You will make it as a blank or a hyphen portion. All the 0, 0, 0 remains same for 0 and 1, and the change happen only at the LSB bit. That is why you put as hyphen. Okay, so the same operations is repeated for the pi also. Thus, you made pair, and from the pair group, you just compared the 0th group with first group and check whether is there any group which can be combined to become a quad. Next table is quad. To form the quad table, you are comparing the pair groups and you are checking whether there is a one bit change for any of the pairs, so that you can combine that to become a quad. Okay, so again, this operation is repeated for the making the quad also in the case of pi also. Okay, so thus you made the quad, and from the quad you understood that no quad groups can be combined to become octet. So you are stopping the process. Okay, now we are going to write the minimized product of some expression. Actually, we have seen this question for SOP. Now I am going to write the minimized POS expression. So the change happens from this step onwards. Okay, so now we are going to represent what is this unticked pairs, unticked terms. So you found out that all the previous tables are all tick. There is no unticked max term or group was there. So you don't need to bother about that. The only untick happens in the quad table only. So you are going to represent this quad value. So how do you represent this quad in if it is in POS, if it was in pi, if it is in pi, this is actually SOP. This is actually SOP, isn't it? This is SOP representation. If the question was for POS, I'm going to write the POS representation here. So if it was POS, how will represent this 0, 0? It is actually B and C itself. It is not B bar and C bar. So it will be B plus C. Yes, this is going to be B plus C. It's going to be B plus C. Okay, what about this representation? It is B plus D bar. This is B plus D bar. And what about this? It is C bar plus D bar. Yes, it is C bar plus D bar. So what I'm trying to say is that if the question was to perform for pi, all the steps till this point is same for SOP as well as POS. Okay, so only in this, from this step onwards, you need to think about how to represent my unticked terms. Okay, for SOP we will be writing like this. For POS, if the question was POS, you will be writing like this. Now we are going to check what are the prime implicants or what are the essential implicants from this. So this is actually B plus C. This is going to be B plus C. The same is repeated here. This is going to be B plus C, and this is going to be B plus D bar. Okay, this is going to be B plus D bar, and this is going to be C bar plus D bar. And you are marking the terms 0, 1, 8 and 9, because in the question it was these are the max terms given 0, 1, 3, 7, 8, 9, 10, 11 and 15. So this term covers 0, 1, 8 and 9. So you take a tick mark on under that max terms 0, 1, 8 and 9. And here also 1, 3, 9, 11, 1, 3, 9, 11 and 3, 3, 11, 7, 15. So 3, 11, 7, 15 you put a tick marks. And you check any of the term can be avoided or not. If there is any term which is redundant and you found out that the 1, 3, 9 and 11 is can be mapped in B plus C 0, 1, 8, 9 as well as in 3, 11, 7, 15. See, 1 is present here, 3 is present here, 9 is present in this term, and 11 is present in this term. So you can avoid this B plus D bar. This can be avoided. So B plus C as well as C bar plus D bar is only what we require, isn't it? So you can represent that as the answer will be in POS. If the question was in POS, minimize POS, the answer will be it will be B plus C. It will be B plus C. Actually, product of sum, isn't it? B plus C dot C plus D bar. C bar plus, not C plus D bar, C bar plus D bar. Okay, so this is how you will perform the operations when the question was to minimize in POS. Okay, the question was just like instead of sigma here, given here, if the question was pi am, if the question was pi am 0, 1, 3, 7, 8, 9, 11, 15, this is how you have to perform the operation. All these steps remains the same, just like what you have done in in the case of sigma. So all these steps remain the same, and the change happens from this step onwards. When you are going to represent the value, you will be representing this POS format. Okay, and then you check whether any term can be avoided, whether there is any term that is redundant, okay, which can be mapped using other terms. So you found out that B plus D bar is a repetition. So the answer will be B plus C and C bar plus D bar. So answer is B plus C multiplied by C bar plus D bar. Okay, yes. Now there is one more thing I need to add, that is if the question was, if the question was sigma m 0, 1, 3, 7, 8, 9, 11 and 15, and you are asked to find out the minimized POS. The question is given as sigma m 0, 1, 3, 7, 8, 9, 11, 15, and you are asked to perform the pi value. Then what you have to do? Don't cut the sigma m and put as pi m. You know that the terms which are not in this sigma value will be the pi m, isn't it? In that case, you have to represent it as pi m within bracket the terms which are missing here. That is pi m 2, 4, 5, 6, then 10, 12, 13 and 14. Clear? That is a different case because the question is given as sigma m itself and you are asked to find out the pi value. In that case, the missing terms will be written as pi m and the operation is repeated. Okay, but what I tried to explain in this question is instead of giving the sigma m, I wrote it as pi m itself. So this 0, 1, 3, 7, 8, 9, 11 and 15 are the max terms which gave you 0 for the circuit. Okay, hope you understood the difference. So I am stopping here. We will see an example with a don't case in the next video.